Meta just made a move that could fundamentally reshape how AI companies build their hardware. For years, everyone building cutting-edge AI chips has relied on one company to manufacture them, Taiwan Semiconductor Manufacturing Company, or TSMC. They are the world's most advanced chip factory, but Meta is about to abandon that strategy entirely. They're signing a $6.5 billion deal with Samsung to build their next generation of AI accelerators, and this change has massive implications for the entire industry. Here's the context you need. Meta's been designing custom chips called MTIA, that stands for Meta Training and Inference Accelerator, to power their AI models and reduce their dependency on Nvidia GPUs. Those Nvidia chips are expensive and in short supply. Custom silicon lets Meta build exactly what they need, tailored to their workloads. But manufacturing these chips at scale requires a world-class foundry. Samsung is betting big on becoming that foundry for AI, and Meta is placing an enormous bet alongside them. The deal covers hundreds of thousands of wafers. That's the thin disks of silicon that get sliced into individual chips. Samsung will manufacture Meta's third, fourth, and fifth generation MTIA chips on their cutting-edge 2-nanometer SF2 process. That's some of the most advanced manufacturing on Earth. This isn't just a business transaction, it's a strategic pivot that signals how the next generation of AI hardware is going to get built. And here's where it gets interesting. To understand why Meta's making this move, you need to know what the last few years have looked like for AI companies. Ever since Transformers revolutionized AI around 2017, everyone's been on a treadmill of exponential scaling. You need bigger models, which need more compute, which means buying mountains of Nvidia GPUs. Nvidia's processors are incredibly powerful, but they are also expensive, and they're optimized for general-purpose computing, not specifically for Meta's workloads. Here's the tension. Nvidia's GPUs are fantastic, but they're not purpose-built for what Meta does. When you're running training and inference for systems like Llama or recommendation engines serving billions of people every second, your bottlenecks are different. You have specific memory requirements, specific bandwidth needs, specific architectural quirks that matter, so Meta decided to design their own. MTIA is that chip. The first MTIA came out around 2023, and the second generation followed. Now Meta's committing to the third through fifth generations on Samsung's 2-nanometer process. That's a lot of chips, spread across years of production. The contract reportedly covers hundreds of thousands of wafers annually. For context, a single wafer can become dozens of chips, depending on size. We're talking potentially millions of MTIA processors rolling off Samsung's fabs to power Meta's infrastructure. This isn't a casual experiment anymore. This is Meta betting the company, or at least a huge chunk of their AI infrastructure future, on building custom silicon at massive scale. But there's something else happening here that's even more interesting. So what's actually special about Samsung's 2-nanometer SF2 process? Let's break down what makes it different from what TSMC has been doing. The nanometer number is a marketing shorthand. It doesn't literally mean the transistors are 2 nanometers wide anymore. It's more about the technological generation. But what matters is that Samsung's SF2 process uses something called gate-all-around transistors. Imagine a traditional transistor like a gate controlling a bridge. Electricity flows from one side of the bridge to the other, and the gate switches it on or off. With older designs, the gate only surrounds 3 sides of the channel, but gate-all-around wraps the gate completely around all 4 sides. That gives you more control over the electrical current, which means you can make transistors switch faster while using less power. It's a fundamental improvement in how chips operate at extreme density. At 2-nanometer scale, with gate-all-around architecture, you get more transistors per square millimeter than you've ever had before. More transistors means more processing power in the same physical space. That directly translates to more AI performance per dollar, which is Meta's whole goal here. Samsung's been working on this process for years, and this Meta deal validates their bet. It's telling the market that Samsung is competitive with TSMC at the absolute cutting edge. And for Meta, it means getting access to a manufacturing partner who's invested in keeping their process leading edge, because Meta's a major customer now. This is where the real competitive advantage starts to click into place. Let's make this concrete. What does this actually mean in terms of computing power and performance? Meta's current infrastructure runs on massive data centers filled with servers. Each server has multiple GPUs, or in newer deployments, MTIA chips. When you use Llama, when you get recommendations on Facebook, when you interact with any Meta service that touches AI that's running on this hardware. Nvidia's latest flagship is the H100 GPU. It's got about 80 billion transistors and costs around $40,000. It's incredibly powerful, but also incredibly power-hungry. An MTIA chip, by comparison, is designed specifically for Meta's model architectures and inference patterns. It doesn't need to be a general-purpose workhorse. That focus lets Samsung and Meta design something more efficient. Think of it like this. An Nvidia GPU is like a powerful truck that can haul anything. But if you know you're only ever hauling hay, you can design a farm trailer that's lighter, cheaper, and better optimized for that specific job. The MTIA is Meta's hay trailer, engineered specifically for Meta's workloads, now scaled across hundreds of thousands of wafers. Each wafer becomes dozens of chips. That's millions of custom processors deployed across Meta's infrastructure, all working in concert. With the 2-nanometer process, each of those chips is denser and more power efficient than the previous generation. Meta's goal is 5 gigawatts of computing capacity by 2030. So here's the question: why Samsung instead of TSMC? TSMC has been the default choice for years. They've got the most advanced processors, the most experience, the most market share. Practically every cutting-edge chip in the world gets made at TSMC, but there's a strategic angle here that's fascinating. First, there's the Samsung foundry perspective. Samsung's been trying to gain ground in the advanced foundry business for years. They've got the technical capability, but TSMC's had first-mover advantage. This deal, reportedly $6.5 billion, one of Samsung's largest AI contracts ever, is Samsung proving they can compete at the cutting edge. It's also a massive validation of their 2-nanometer process. If Meta's betting this much on it, Samsung's clearly built something extraordinary. But from Meta's perspective, it's about supply chain diversification and leverage. TSMC's capacity is constrained. Everyone wants access to their most advanced processors. By splitting manufacturing between Samsung and TSMC, or potentially moving entirely to Samsung, Meta reduces their dependency on any single foundry. If TSMC has a problem, Meta's not completely stranded. There's also a financial element. Samsung might offer better pricing or terms for a massive multi-year commitment. $6.5 billion gets you significant leverage in negotiation. Meta can probably secure favorable pricing, priority capacity, and maybe even engineering support specifically for their chip designs. This isn't just about technology. It's about economics and strategy. Meta's essentially saying, we are big enough, we are strategic enough, that we can change our manufacturing partnerships. This move is changing the foundry market dynamics. This deal has massive ripple effects through the entire AI industry, and most people aren't talking about it. Let's start with Nvidia. Nvidia's been the default AI chip company for years. Nearly every major AI company buys their GPUs. OpenAI, Google, Microsoft, Meta, all of them. But Meta's now building its own. Google's been building TPUs for years. Tesla's got custom chips for Dojo. Amazon's got Trainium and Inferentia. All the major tech companies are moving toward custom silicon. This trend puts pressure on Nvidia. It's not an existential threat. Nvidia will keep selling GPUs to companies that don't want to build chips in-house. But it shrinks the addressable market. If every mega-cap tech company eventually moves most of their workloads to custom silicon, Nvidia's growth slows. That's a meaningful change in market dynamics. For Samsung, it's validation. It says their foundry business can compete and win contracts that matter. Samsung's been investing billions in advanced manufacturing. Landing a Meta contract alongside their existing Tesla business proves that's a sound strategy. For the broader AI chip market, it's a signal that in-house silicon is the future for companies at scale. It's not something only Google and Tesla do anymore. It's the standard path for companies with sufficient budgets and manufacturing partnerships. And here's the deeper implication. This accelerates the commoditization of AI compute. You're trying to understand the AI chip landscape. here's what you need to watch going forward. First, pay close attention to fab capacity and who's building where. When major companies announce foundry partnerships, especially multi-year, multi-billion-dollar deals like this Meta-Samsung agreement, they are signaling their confidence in that manufacturer's roadmap. Samsung just proved they can handle one of the world's biggest tech companies' most critical manufacturing needs. Second, track the change away from Nvidia. We're not talking about Nvidia disappearing, they are not. But watch how many companies announce their own AI chips. Each announcement shrinks Nvidia's total addressable market. That doesn't mean Nvidia's stock crashes, but it means Nvidia can't grow forever just by selling more GPUs. They need to expand into software services, and AI platforms. Third, understand process nodes and what they actually mean. When a company announces a 2-nanometer chip, they're not talking about literal nanometer sizes, but the number does indicate that it's at the latest generation of process technology. More transistors, better efficiency, faster speeds. That's what drives performance improvements generation to generation. Finally, watch Samsung and TSMC's competitive dynamics. Samsung's now competing for foundry market share at the highest end. TSMC is not going to disappear, they are still the leader, but the market's becoming more competitive. That's good for customers and bad for anyone betting on one foundry having permanent dominance. So here's what this all means. Meta's $6.5 billion bet on Samsung is a signal that custom silicon is the future for big tech, that Samsung can compete with TSMC at the cutting edge, and that the AI hardware market is fundamentally shifting. It's not one company owning everything anymore. It's diversification, it's competition, it's the inevitable cycle of technology industries maturing. Meta's investing in this because it serves their business. Building custom chips for AI workloads lets them cut costs, improve performance, and reduce dependency on Nvidia. By 2030, when they hit that 5-gigawatt target, a huge chunk of that compute will be running on MTIA processors made by Samsung. That gives them control over their own destiny instead of being at the mercy of an external supplier. For you, as someone who cares about AI and tech, this matters because it affects the pace of AI development. Cheaper, more efficient custom silicon means more compute available for training and deploying AI models. It means smaller companies can potentially access cutting-edge hardware through partnerships. It means the competition in AI hardware intensifies, which drives innovation. The takeaway: watch the hardware layer. Most AI news focuses on model capabilities, new LLMs, and software breakthroughs, but the hardware underneath is equally important. Companies that can build custom silicon are going to move faster and hit higher performance than those buying off the shelf. This Meta-Samsung deal is the latest proof that that trend is here to stay. Follow for more AI news daily.